Okay, kind of a 2-day lesson here. Right triangle trigonometry. Doesn't matter whether I'm teaching plain trig or college trig, there's at least 1/3 of the students who are confused about some aspect of this. So some of you will see it right away, others will take time. This is the most foundational part of trigonometry. If you take a trigonometry course, everybody is going to expect that you can solve a right triangle using SOHCAHTOA. It is like the one thing that people say everybody can do. Every year I have a few people who say this is impossible, people can't do this. Never had a student who was willing to sit down with me and try to figure it out. Never had a student who wasn't able to figure it out. Had many people who say it's just too tough and I'm not going to do it, and they just never learn it. But I've never had a student who actually said, can you please try to help me out here? Every single student has done that. We've been able to figure it out. 100%. All right, here we go. Given a right triangle, has to be a right triangle. Must be a right triangle. That triangle has 3 sides. Anybody want to describe the sides, the names of those sides? One starts with an H. Hypotenuse. The hypotenuse is always the longest side. It is across from the 90-degree angle. The other 2 sides depend on which angle we are talking about. I would like to place the angle at the bottom here. I'm going to call it theta. Does anybody know what the other 2 sides are if one is the hypotenuse? Adjacent and opposite. Very good. Do you know which one is the opposite and which one is the adjacent? Okay, you are correct. Let's talk about why, and this is one of the biggest points of confusion. If you look across from the angle, that is the opposite. Because it sits across from the angle. So now we say the last one is the adjacent. I want to show you why it's the adjacent one. Can somebody tell me who is sitting adjacent to Greta? We could either say Nikki or we could say Sophia. Either one. It means that they are sitting next to. Next to. So when we say adjacent, it means next to the angle. Is this side next to the angle? It's across from the angle. If you draw the angle, hopefully you can see that it's made up of the hypotenuse and the adjacent side. That's what the word adjacent means. Next to. There's an acronym that we've developed in order to talk about solving right triangles and these relationships. And it is SOHCAHTOA. Anybody know what the S stands for? Snitches get stitches. Yeah, what's up, dog? Yeah. Yeah, they're busting, man. See, now I'm going to lose 20 people from my YouTube channel because they just heard me say that. They're like, that's the dumbest guy in the world. You think I'm going to get more likes because of that? But yeah, they can hear me. All right. That's the whole idea. All right, so what does the O stand for? Opposite. Sine. And what does the H stand for? Hypotenuse. So therefore, sine is the opposite side divided by the hypotenuse. And so this acronym can help you see that and figure that out. Sine is the opposite divided by the hypotenuse. What does the C stand for? Cosine. And what does the A stand for? Adjacent, and the H stands for hypotenuse. So cosine is the adjacent divided by the hypotenuse. And then the last one, T stands for Tanner. And O stands for opposite, and A stands for adjacent, which we've just said. So tangent is opposite divided by adjacent. And we don't need to talk about those three. You don't use them when you're doing the right triangles. Are you okay with that? Yeah. All right. Now, I'm going to give some of you an opportunity to just make a connection from yesterday. Some of you will use this and some of you won't, and that's fine. But I told you that I never learned SOHCAHTOA. So how did I then think of sine? I used what we said yesterday. I called these sides X, Y, and R. Instead of using adjacent, hypotenuse, and opposite, I called them X, Y, and R. So sine, I said, was Y over R. Cosine was X over R. And tangent was Y over X. I just thought of it as those. That's how I learned it. That's how I did it. So I will teach SOHCAHTOA. That corresponds to what you learn in geometry, and it's most traditional. But I just want to let you guys know it's no different than what we talked about yesterday. The only difference is the radius always going to be 1, or is the hypotenuse always going to be 1 for these triangles? No, but in the unit circle it was, correct? So that's the difference. All right, let's try a couple examples. The first one, find the exact value of the 6 trigonometric functions for theta given the legs of the triangle are 15 and 8. Sorry about that. I always forget to change that. Instead of 6, we're going to do 3. So I have a triangle. I'm going to call that theta. And I'm going to, I have 2 legs. I have 2 legs, so I'm going to call this leg 15, and I'm going to call this leg 8. Sine of theta, cosine of theta, tangent of theta. What I want you to do is spend 2 minutes working with somebody, and I want you to see if you can, number 1, label these as opposite, adjacent, and hypotenuse. And second of all, see if you can come up with what the hypotenuse is. Go. Talk. Figure out something. Go. 5, 4, 3, 2, 1. Can anybody tell me what side is 8? Opposite, adjacent, or hypotenuse? Opposite. How about this side up here? Hypotenuse, and 15 should be the adjacent. That's the first check, is where you're able to do that. Any questions how I came up with those? Okay, let's talk about the slightly more challenging part. How do I come up with the hypotenuse? Pythagorean theorem. Let's try to come up with that with this angle. I get why you wanted to double it, but the fact is we don't know if it's a 30, 60, 90 triangle, do we? So we're going to use a Pythagorean theorem to figure out this other side. The right triangle trigonometry is great because we can always use the Pythagorean theorem. So these are the legs. So we're going to say 8 squared is 64 plus b squared. What's 15 squared? 225 is equal to c squared. So 64 plus 225 is? So if c squared is 289, what is c? Very good. You have to square root it, and you get 17. Now that I've solved the triangle and I have all 3 sides, I can now list sine, cosine, and tangent. What is sine going to be? Opposite over hypotenuse. 8 over 17. Cosine. Adjacent over hypotenuse, so 15 over 17. And tangent is opposite over adjacent, so 8 over 15. What do you think?
That's easy again. Yeah, you messed up a little bit.
What'd you mess up on?
Oh, I just put 16 for like 5.
Why'd you do that?
Okay.
Oh, because you doubled the 8.
Yeah.
I got you. Hey, that's reasonable. I got you. All right, so let's try this one. Here, I have sine of theta, cosine of theta, and tangent of theta. I want to express all three of them. All three of them. I'm going to need to find the missing side of the triangle. What do I use to find the missing side of the triangle? Pythagorean theorem. So I'm going to call this side B. So somebody set it up for me. What is it? 5 squared plus B squared is? Good. So 25 plus B squared is equal to 169. You dork. Okay. So I subtract the 25, I get B squared is equal to 144, so B is 12. But you're always right. I've never known you to be wrong once in my life. Okay, so what is sine, Josh? Nikki's got it. That was Zoe. She says that's the opposite, and that's the hypotenuse, and this side is the adjacent. So she says the opposite divided by the hypotenuse is 5 over 13. She also says that the cosine is going to be 12 over 13. The adjacent divided by the hypotenuse, and tangent is?
5 over 5.
Take out a calculator or phone or something you could calculate with. Take 20 seconds and talk to your partner and make a guess for how big you think the angle is. Make a guess. Go. 20 seconds. Go. How big the angle is. Somebody out there, tell me, what was your guess?
Somewhere between 90 and
I heard 33. Anybody else? 69 degrees? I feel like I'm in a 4th grade classroom. All right, so let's try this out, okay? I'm going to show you how we can actually calculate this. This is kind of cool, okay? First of all, in your calculator, your phone, you need to be working in degrees and not radians. So I press mode on my calculator, and I'm going to go down over to degrees. So a lot of you guys are already going to have that on. These calculators default automatically to radians. So I moved mine over to degrees. You're going to be able to see whether or not it's correct in just a second here. Second of all, what I want to do is I want to figure out the angle. So if you know sine is equal to that, then the way that we figure out the angle is instead of pressing sine, you press second sine. Sine inverse is what it means. For those of you who took first semester math for college, we talked about inverse functions. This is an inverse function that we're using. And all we have to do is type in 5 over 13, and it gives us the angle. This angle right here is 22.62 degrees. You're only 10 off? It's pretty far. I thought your calculator is 10 off. You were 10 off on your guess. That's fine. I thought your calculator is 10 off. I'm like, there's a big problem there. Okay. All right, watch. You don't have to choose sine. You can do cosine and press, cosine inverse and type in 12 over 13. And you should get the same thing. Or you could try tangent inverse and type in 5 over 12. And you should get the same thing. You're going to have to use that operation on your assignment today. Okay? All right, one more, then we're going to get to our assignment for a little bit here, and we're going to practice one more piece. Here we go. So, I have a triangle here. I want to find this side so I can complete the triangle. What am I going to do? Two squared plus 4 squared is equal to c squared. 2 squared is 4 squared. So 20 is equal to c squared. So c is the square root of 20. Can you simplify the square root of 20? Because you have the square root of 4 times the square root of 5, that becomes 2 roots of 5. So c is 2 roots of 5. Take 30 seconds and see if you can label it as opposite, adjacent, and hypotenuse. Go. Opposite, adjacent, hypotenuse. Go. Okay, most people see this. 2 roots of 5 is the hypotenuse. Good for you. In order to find the opposite, start the angle and go across. That is the opposite. So 2 is the adjacent. So I'm going to write this out, sine, cosine, and tangent. Sine of theta is equal to what? This thing, 4 over 2 roots of 5. Can you simplify that? Yeah, 4 over 2 is 2, so I have 2 over the root of 5. Can you leave the root of 5 in the denominator? So you multiply the top and bottom by the root of 5, and you get 2 roots of 5 over 5. Yep. Sine is the opposite divided by the hypotenuse. So 4 over 2 roots of 5. 4 over 2, 2. Can't have the square root of 5 in the denominator. So we multiply the top and bottom by the root of 5. 2 times the root of 5 is 2 roots of 5. Root of 5 times the root of 5 is 5. What's cosine going to be? No. Oh, root of 5 over 5. Yes, you have 2 over 2 roots of 5. Morning, sir. What can I do for you? Notice how the 2's cancel. So I get 1 over the root of 5. Can you leave the root of 5 in the denominator? So multiply top and bottom by the root of 5. And we get the root of 5 over 5. And finally, tangent is going to be what? 4 over 2, which is 2. Take out your worksheet. Take out your worksheet. Okay, so we're going to be breaking this lesson up into 3 parts, okay? Your test would be next week on most likely Thursday or Friday. Thursday or Friday. Part of that depends on if we have school tomorrow or not, okay? So, just want to show you what you start with, okay? I don't want you to start with problems 1 through 6. I want you to start with problems 7, 8, and 9. 7, 8, and 9. And I'm going to do one problem with you. I'm going to give you time to just work a little bit, okay? All right, 7, 8, 9, and 10, excuse me. So I will do problem number 9 with you. It says to determine the missing angle. So you want to find theta. The first thing that you need to do in order to find theta is you need to identify the opposite, the adjacent, and the hypotenuse. So I'm going to point to a side, and you tell me which one it is. This side right here. Opposite. So, this is where the critical thinking comes in. If I'm given the adjacent and the hypotenuse, if I'm given the adjacent and the hypotenuse, which one do I use? Sine, cosine, or tangent? I use cosine because that one has the adjacent and the hypotenuse. So you're going to use cosine. Does everybody see that? So let's set up our trig ratio. Cosine of theta is equal to what? In this picture. Four over 5. What do I do on my calculator to find the angle? Yep. You turn on your calculator and you go cosine inverse of 4 over 5. And you get 36.87 degrees. What I want you to do right now in the last 5 minutes of class, I want you to try problems 7, 9, and 10, or 7, 8, and 10. See if you can get those right on your own. I'm going to come over and help you. Check with your peers to see if you're coming up with the same thing. That's where we're going to end today. Good work.